The last lesson of this chapter is number classification, and it's called the real numbers. So I'm going to scroll down to the diagram because I know these definitions. So the most restrictive group is here in the middle, the natural numbers. And those are your counting numbers. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so on. It's not zero. It's not a negative number. It's not a decimal. It's not a fraction. It's just 1, 2, 3, 4, 5, 6, 7, 8, so on and so on and so on. That's in the innermost circle, which means if you are a natural number, you are also every single thing above it. You're not irrational. That's its own separate bubble. The next group are the whole numbers. So what's different between the natural numbers and the whole numbers? 0. It is the only number that is uniquely whole and not natural. So the only special thing there is 0. So I'm actually going to do some writing on here. Your natural numbers are things like 1, 2, 3, so on and so on. Your whole numbers are those and 0. Your integers are your negative numbers. So negative 1, negative 2, negative 3, so on and so on and so on. Plus 0, plus 1, 2, 3, 4, 5. Your rational numbers are your fractions. They are your decimals that end. They are your decimals that repeat. Rational numbers are fractions, decimals that end, or decimals that repeat. Everything is real. Well, I shouldn't say that. Most things are real. Irrational numbers are pi and square roots of NPS, non-perfect squares. In other words, if it's a square root and you can't tell me what it is, like root 300 from our last lesson, that's an irrational number. An irrational number is technically defined as a decimal that never ends and never repeats. For us, that means pi and the square root of non-perfect squares. So, write all the names that apply to each. This first thing, root 3. Well, I don't know the square root of 3, so it's the square root of something that doesn't work. That means this is irrational, and we can abbreviate that IRR. The next number is a decimal, 0.85. It's negative 56.85, but it's a decimal that ends. That means it is rational, RAT. Root 9 thirds. Root 9 is actually 3, and 3 over 3 is 1. So you got to do a little digging here to find out what kind of number that is. 1 is a number I count with, so it's natural. But if you're natural, that means you're also a whole number, you're also an integer, and you're also rational. You must list all the groups except for real. I don't need you to write real right on this group. So your choices are irrational, rational, integer, whole, natural. Just making sure you're including everything above whichever group you choose. Next, state whether each is rational, irrational, or not real. Root 10, square root of a number I don't know, so it's irrational. 3 divided by 0. You're saying, hey, it's a fraction. And you're technically correct with one problem. A rational number is defined as a divided by b, where a and b are integers, so far so good, and b is not 0. The denominator is 0. That's a problem. Divide by 0 means not real. Root 1/4. Would it surprise you to find out that that's rational? Because it's 1/2. The square root of 1 is 1, and the square root of 4 is 2. So the square root of 1 over 4 is 1 over 2. 1/2 is a proper fraction, so that's rational. Root negative 17 is also not real. Remember, a square root is saying what times itself gives me this number. And in no way can you ever do something times itself and get negative 17, because to get a negative number, you have to have a positive times a negative. So not real is things divided by 0 and the square root of negative numbers. Not negative square root of negative. Last bit here, give a number between the two given numbers. So sometimes this is simple. Between 1 and 2, literally 1 point anything. 1.1, 1.01, 1.23, 1 point anything. Let me give myself some space here so it doesn't do that again. 1 point anything. For the next bit, 3/5 and 4/5, you're probably looking at saying, oh yeah, well, wait, what? How are we supposed to put something between 3 and 4? We can't put 3.5/5, and you can't. You cannot give me a decimal and a fraction. Don't do it. But if I were to say double all of those, 3/5, double both of them, it's 6/10. 4/5, double them, it's 7, 8. I can't talk this morning. 8/10. Those are the same fractions. If you double everything, it's the exact same fractions, just written in a different form. Can you tell me something between 6/10 and 8/10? Of course you can. It's 7/10. So whole numbers, easy. Fractions, if you can't put a numerator in between what they gave you, double everything and you'll be able to. And square roots, literally, you could give me anything from root 27 to root 34. Just give me root and then a number between 26 and 35.